This is section 4.7, the ambiguous case. From geometry, you know that the measures of two sides in a non-included angle, side-side angle, do not necessarily define a unique triangle. Consider the angle and side measures given in the figures below. So what if we had the side A was 0.3 and C was 2? Well, we'd have the height with a 30-degree angle is too high for this side to reach. So this side would just swing. And so in this case, if we compared this side to the height, we wouldn't have a triangle at all. Now, if the height was exactly 0.5 and this side was 0.5, then we'd have a right triangle. If this side was 1 inch long and we compared that to the height, it would be slightly longer than the height, so we'd have a triangle. But we could also swing this end around. We'd still have a 30-degree angle. We'd still have a 2-inch side, and we would still have a 1-inch side, and we'd have another triangle that fits the criteria that's given. So this is actually the other triangle. So we could have two triangles with this scenario right here. In general, given the measures of two sides in a non-included angle, one of the following will be true. 1, no triangle exists. 2, exactly one triangle exists. Or 3, two triangles exist. In other words, when solving an oblique triangle for this ambiguous case, there may be no solution, one solution, or we could have two solutions. And this kind of summarizes the fact that we're comparing this side A right here to the height and seeing if, well, is there 0 triangles? Is there exactly one? Or could there be two triangles? Now, with this scenario right here, there's another scenario where you have one triangle, and that's if this side and this side were exactly the same length. Or, it says greater than or equal to, if this side was longer, let's say it swung all the way over there, there'd be one triangle, because this would definitely be longer than the height. But then if you swung it way over here, this triangle right here would not have the same given angle. It would have its supplement. Now we also have the case where the angle is obtuse. And if A is shorter than B, then that side can't reach down to form the triangle. If A is longer than B, then it reaches and you have one. So with obtuse angles, you either have no solution or you have one triangle. Let's look at a case where we have a right triangle. Now, before we take the test or quiz, you're not going to know what you have, but I'm telling you this is going to be a right triangle. So here's how we start the problem when we have let A equal 30 degrees, A is 4 and B is 8. We solve all possible triangles. So we draw this angle right here. This is angle A, and it is 30 degrees. So this is side A across from angle A, and that length is 4. Let's put angle B down here, and it says side B is 8, so this side is 8. Now we want to compare this side right here to the height of the triangle. We have the sine of 30 degrees is equal to opposite over hypotenuse, h over 8. Let's multiply by 8, so h is equal to 8 times the sine of 30 degrees. Sine of 30 degrees is 1/2, so this ends up being exactly 4. So it turns out we have a right triangle. So that's angle B down here, which is 90 degrees, and angle C up here, that's going to be 60 degrees because we know it's a right triangle. So A is 30, B is 60, actually B is 90, B is 90, and C is 60. Well, now we got to find this side right here, side C. We know A is 4, B is 8, and we got to find C. We have the cosine of 30 degrees is equal to side C over 8. So C is equal to 8 times the square root of 3 over 2, which ends up being 6.928. Let's look at a case where we have no triangle. Let A equal 45 degrees. So we'll put A in the same place. So we're going to put A down here, 45 degrees. A is 4 and B is still 8. And we're going to compare 4 to the new height. So the sine of 45 degrees is equal to h over 8. So now h is equal to 8 times the sine of 45 degrees, which is 5.657. Now that's longer, this is longer than this side, so this side isn't long enough to reach. It's going to hit, maybe about right here. So it's just going to swing right there. We don't have a triangle, so all we have to do is say none, and we get to move on. Now this is a case where we have two triangles, and this is the one that requires the most work. So let's put the 25 degrees down here, 25 degrees. This is angle A, and we're going to pretend that we don't know if it's a triangle yet or not. So we'll make that side 4, this side 8, and we have to compare the side that's 4 to the height. We have sine of 25 degrees is equal to opposite over hypotenuse, and h turns out to be 8 times the sine of 25 degrees, which is 3.381. So this is short enough so that this side will actually touch. So we have, here's the one triangle. So let's solve the first triangle, A, B, and C, and we have A1, B1, C1. So A is 25 degrees. We know that A is 4, and we know B is 8. So here's angle B right here. Here's angle C, and this is side C. We have the sine of 25 degrees over 4 is equal to the sine of B over 8. And let's cross multiply. So 4 sine B equals 8 sine of 25 degrees. And we have sine of B is equal to, we need to take 8 times sine of 25 degrees and divide that by 4. And it turns out to be 0.845. Now that's what I'll write as a rounded answer, but I'm still going to use the exact answer that is sitting in the calculator. So now we have to take the inverse sine of 0.845, which is the second function of the sine key. So angle B ends up being 57.697 when we work it out on the calculator. So that's 57.697. Well, now the handy part is we can just add 25 to this. So we take 57 plus 25 and subtract that from 180. And when we do that, we get 97.303 degrees. So now we know all the angles, and all we have left to do is find C. Well, the sine of 25 over 4 is equal to the sine of 97.303, and I'll have that answer sitting in the calculator over C. And so we'll cross multiply. So we have 4 sine 97.303 is equal to C times the sine of 25. So we just have to divide that multiplication by the sine of 25, and C ends up being, let me find it here, 9.388. So 9.388. So there's the first triangle done. But we have a second triangle because we can swing this one over, and we have a brand new triangle sitting right here that has the exact same criteria. So we have an angle A is 25, side B is 8, and side A is still 4. So we have A1, B1, C1, or actually 2. This is the second triangle. And A2, B2, C2. Now we have to have the same exact criteria that was given. So angle A is still going to be 25 degrees, A is still 4, and side B is still 8. Well, notice that we've created this isosceles triangle right here. So this angle, which is B, that's this one, 57.679, is the same as this angle right here. Well, the angle we want, B2, is sitting right there. So if these two are the same, this one is the supplement of this angle, so we just need the supplement of 57.697. And when we subtract this from 180, we get 122.303 degrees. So we get that one just by doing the supplement, adding, subtracting from 180. Well, now we can add 25 to this one and subtract that from 180, and we get 32.697. So the second triangle's answers fall out pretty quickly. Now we have one more law of sines to do. We have sine of 25 over 4 is equal to the sine of 32.697 over C, over C2 really. And when we cross multiply, divide by sine of 25, C2 ends up being 5.113. Let's look at a case where we have one triangle, but of course we're not going to know that before we start working with the problem. So let's put the angle, the given angle, down at the bottom left again. That's going to be 35 degrees. Side A is 10 and side B is 8. So we have angle B down here, C, A's here, and this is side C. Well, let's get the height. And the height can't be more than 8, because if the height was more than 8, then it wouldn't be a triangle. It would just be straight up and down. So we don't even have to find the height on this one. We just know it's going to work. So there's definitely a triangle sitting here. Now, if we swung this all the way over, we wouldn't have the given criteria anymore. We'd have this new triangle, and the given angle would be the supplement of what we were given originally. So we don't have 2 triangles. We only have 1 triangle. So I need A, B, and C. Those are the angles, and side A, side B, and side C. But I already know A is 35 degrees. I know A is 10, and I know B is 8. So we have sine of 35 over 10 is equal to the sine of B over 8. And we need to cross multiply. So we have 10 sine of B equals 8 sine of 35. And we have sine of B equals 4.5886, keep on going. And we need to divide that by 10, so that's still there. Sine of B is equal to 0.45886. We have to take the inverse sine of 0.458, and we get 27.314. So B is 27.314. We can add 25 to that. Or excuse me, you can add 35 to that, and subtract that from 180, and it ends up being 117.686. Well, now we need the sine of 35 over 10 is equal to the sine of 117.686 over C. And when we cross multiply, do a little division, C ends up being 15.438. What if the given angle is obtuse, 134 degrees? So let's put the angle down at the bottom left again. So this is going to be 134 degrees. And side B, this would be angle B if we can connect that side. Side B is 8, and side A is 15. Well, this is definitely long enough to reach back to the bottom, so we have 1 triangle in this case. So we have A, B, and C. A is 134 degrees. We have A, B, and C, the sides. A is 15 and B is 8. We have the sine of 134 over 15 is equal to the sine of B over 8. So B is equal to, when we cross multiply, divide by 15, and take the inverse sine, we get a value of 22.560. So this is going to be 22.560. Now we're going to add that to 134 and subtract from 180, and we get 23.440. Well, now we just need sine C. Now we can take the sine of 134 over 15 and set that equal to the sine of 23.440 over C. C is equal to 8.295. And we get to obtuse, no calculator? No, you can use a calculator, no triangle. Let A equal 128 degrees, B is 8, and A is 4. So let's make a 128, or at least an obtuse angle. And so side A is 4, and here's angle B if we can finish the triangle. So side B is 8, and 4 is not long enough to reach down to the bottom, so we have none. We don't have a triangle here.